We want to look at how can we answer any probability question of any continuous random variable using either PDF or CDF. So let's look at to answer any probability question of any continuous random variable except normal, because for normal we know we have these Z tables which we use to answer probability questions, except for normal. For any other continuous random variable, we can use either PDF or the CDF. So we can use either PDF or we can use either CDF. So for PDF, what we do is we integrate PDF. We integrate PDF to find the probability the continuous random variable lies in some interval. This is because we know probability is area under PDF, right? Because remember, we said area under the PDF gives us probability. So we integrate the PDF over that interval, we get the probability the continuous random variable lies inside the interval. We can, or instead of integrating PDF, we can use expression for CDF. Where we know, okay, fx of x, which is the CDF of x, is defined as probability x is less than equal to x, which in the case of continuous random variable is the same as probability x is less than x, because we know for continuous random variable, we know equal to sign does not matter, right? Equal to sign does not matter for continuous random variable. So we know for any continuous random variable, if you want to find any probability involving it, you can either use PDF or CDF. For PDF, you integrate the PDF because we know area under PDF is probability. And we know we can find area under curve through integration. Or you can use the expression for the CDF, right? So just keep in mind, what does the CDF tell us? It tells us the probability x is less than equal to x, which is the same as probability x is less than x for the continuous random. Now let's look at how we could find different sort of probabilities. Remember, for continuous random variables, we know the probability takes a specific value 0. So what we're interested in finding our probability that lies in some interval. Now this probability could take the form of probability x is greater than a. So for probability x is greater than a, which is the same as probability x is greater than equal to a. Remember, for continuous random variable, equal to sign does not matter, right? Equal to sign does not matter for continuous random. Like we said, we can find this probability using either PDF or CDF. So let's first look at using PDF. We know if we want to find the probability, the continuous random variable lies in some interval, we integrate the PDF over that interval. So if I want to find the probability x is greater than a, which is the same as probability x is greater than equal to a, because the equal to sign does not matter, we just integrate the PDF over this interval. So in general, I can write it the integral from a to infinity fxx dx, where this small fx is just the PDF of x, right? So like we said, we can use PDF to find any probability for continuous random variable by integrating the PDF over that interval. So if you want to find the probability x is greater than a, I can in general write it as the integral from a to infinity. Obviously, we're writing infinity here in general. If your continuous random variable, say, was defined from 1 to 3, and you wanted to find the probability that x is greater than 2. So you can just simply write it as a probability x is between 2 to 3, because obviously the PDF is only non-zero for values 0 to 3. Right? So basically what you're saying is, in general, you can write this as the probability from a to, you can write it as integral from a to infinity, but depending on where your PDF is non-zero, you can make this more specific. If your PDF is only non-zero from 0 to 3, and you want to look at the probability that x is greater than 1, right? So in that case, then you can write this as the probability that x is between 1 to 3, because the PDF is only non-zero from 0 to 3. Okay, that's what we're trying to say over here. In general, I can write it from infinity, but then you can make this more specific depending on how where your PDF is in. So now we can find this probability using CDF also. Remember, the definition of CDF is it's the probability x is less than equal to x. So if I want to find probability x is greater than a, which is equal to probability x is greater than equal to a, using the complement rule, we can write this as 1 minus fx. Because remember, what is fxa? Fxa is the probability x is less than equal to. So here we're applying the complement rule. right? So basically, like you said, you can find any probability using either PDF or CDF. If you have probability of this form, using the PDF, you just integrate from a to infinity. Again, this infinity is in general. You can make this more specific depending on where your PDF is non-zero, right? So using CDF, we can also find this probability by applying the complement rule, right? You can write this as 1 minus fxa because fxa is just probability x is less than equal to. Like, so then moving forward, what if we want, secondly, so what if we want probability x is less than a, which is the same as probability x is less than equal to a, because like we said, equal to sign does not matter for continuous random variable, right? Equal sign does not matter for continuous random variables. It doesn't matter whether you have an equal to sign or not. Again, you can find this using PDF or using CDF. Using PDF, when we want to find any probability, we just integrate the PDF over that interval, because area under PDF is probability, and you find area under curve using integration. So here we can just write it in general as integral from minus infinity to a fx dx, right? You just integrate the PDF. Again, this is here I've written minus infinity in general, but you can make this more specific depending on where PDF is non-zero. For instance, say you have a continuous random variable, its PDF is non-zero from 0 to 3. When you want to find the probability x is less than 1, so I know the PDF is only non-zero from 0 to 3. So I can write the probability x is less than 1 as an integral from 0 to 1. In general, I could write it as from minus infinity to 1, but I know the PDF is only non-zero from 0 to 3. So I can then I can, depending on how the PDF is non-zero, I can then write it instead as, I can make it more specific and write this as probability x is from 0 to 1. Right, and then using CDF. So using CDF, this is simple. This is just the definition of the CDF. Probability x is less than a. Probability x is less than equal to a is just fx. So this is just the definition of the CDF. Now, if we'll ask the card, what if we want to find the probability? X is between A and B. Now, this is the same thing. Now, like the equal to sign does not matter when you're finding probabilities for continuous random variables. Whether I say probability X is between A and B, the probability that X is greater than A less than equal to B, whether we say, the probability X is greater than equal to A less than B, whether, greater than equal to A, or we say the probability X is greater than equal to A less than equal to B, all same thing for continuous random variable, because equal to sign does not matter, because we know the probability takes a specific value 0, all same thing for a continuous random variable. Equal to sign does not matter, does not matter for a continuous random variable, right? So they all mean the same thing. Right, so how do we find this? Now again, we can either use the PDF or the CDF. So using PDF, we can just integrate the PDF over this interval to find the area under the PDF, which gives us this probability. So A to B fx dx. And using CDF, how can we do this? So we can also use the CDF for this. What we just do is, we take fxb, which is the probability x is less than equal to b, minus fxa, which is probability x is less than. So essentially subtracting the probability x less than b from probability x less than equal to b, we're subtracting the probability x less than equal to a, which gives us the probability x lies between. Right, so in this way, using PDF or CDF, you can find any probability for a continuous run. When you're using PDF, you just integrate it over that interval, and depending on what values, for what values the PDF is non-zero, you can make the integral specific, or you can just use simply the CDF.